Questions. Find a domain and range of the functions. Whenever we want a domain means a set of numbers which are allowed to put in function. A set of numbers on which function or machine can work, that is domain. And codomain, range means set of outputs, set of products, that is range. Let us understand in these examples. Find a domain. Say here in this formula, this is minus of modulus x. Now we discuss that this part, it is modulus of x. Domain of a modulus function is R. For every real number, this is defined. Putting any real x, modulus x is defined. For every x belonging to R, this minus x, fx equal to minus of modulus x is defined. We can calculate this value. So therefore, because this is defined, this machine is giving values for every input x belonging to R. So here domain of this function is whole set R. This is domain. Now range. Range means set of images where fx, values of fx lies. So set of all fx, that is a range. Now look here. Say for every x belonging to R, if we take any x in this machine, then first of all modulus x, this value is always greater than or equal to 0 for any x. Therefore, now I am applying minus sign. So minus of modulus x, whenever any number is positive, if you apply minus sign to any positive, it will be converted into negative. So this is less than or equal to 0. Whenever we have, suppose 7 is more than 0. Now if apply minus sign to this 7, so now I cannot continue this sign. Sign is reversed. Minus 7 is less than 0. So this is a formula for fx. So fx is less than or equal to 0. Means all images are 0 or less than 0. This side we are getting all images. So range of this function is minus infinity to 0 close. So this is the set of images. It is range. Now here, find a domain and range of this function. See here, formula is square root of 9 minus x square. Suppose I put here value 2, f of 2. F of 2 is 9 minus 2 square is 4, that is square root of 5. Square root of 5, it is a real number. Here this function, in this function, putting 2 square root of 5 is its image, and this is defined. Now if I put here, suppose 4, if I put 4, square root of 9 minus 4 square is 16. 9 minus 16, that is minus 7. Square root of minus 7 is not in R. square root of positive number is only defined. Square root of negative is not defined. See, always keep remember, square root of 16 is 4 because 4 square is 16, but square root of minus 16 is not minus 4 because minus 4 square is not equal to minus 16. Minus 4 square is 16. So square root of only positive is defined. Square root of negative is not defined. Square root of minus 16 is not minus 4. Square root of minus 7, it is not defined. Here, this is not defined. It is not in R. This is in R. This is 4. 4 belongs to R. But this is not minus 4. Value does not exist in set of real numbers. Such numbers are said to be imaginary numbers, not real numbers. So square root of minus 7 is not in R, not possible. And whenever output is not possible, that means this number 4, it is not allowed to put in this machine. Function you can imagine as a machine. In this machine, if you keep 4, machine is not giving anything. Output is not defined. And if by putting any raw material, if machine is not giving anything, machine doesn't work, then that raw material is not allowed. So 4 is not allowed. Because here in the radical sign, this negative number is produced. Square root of positive is possible. So we have to choose this x such that this must be positive. If this difference is negative, then machine is not working. So for this question, fx is defined. Fx is defined if this function is defined if whatever is in the radical sign, in square root sign, this must be positive. 0 allowed. It can be 0 also, because square root of 0 is 0, that is defined. So if anything you are given in square root sign and you need domain of such function, then this is the beginning that whatever is given in square root sign, its value must be greater than or equal to 0, then fx is defined. This is greater than or equal to 0, that is 9 is greater than or equal to x square, that is x square is less than or equal to 9. Same inequation I have rewritten by changing direction of this inequality. X square is less than or equal to 9. Now whose square is less than or equal to 9? Square of which number is less than or equal to 9? So see, on number line, if this is minus 3, minus 2, minus 1, 0, 1, 2, 3. If you take x equal to 3, 3 square is 9, equal to 9. If you take minus 3, minus 3 square is also 9. So this is also allowed. If you take 2, 2 square equal to 4, 4 is less than 9, so true. If you take minus 2, minus 2 square is 4, 4 is less than 9, so 4 is also allowed. All these numbers can be taken. Not only integers, you can also take 2.5. 2.5 square is less than 9. You can also take minus 2.5. That means all the numbers between minus 3 and 3 are allowed. We can't take 4 because 4 square is 16. 16 is not less than 9. So here maximum value we can take 3 and minimum minus 3. So when x square is less than or equal to 9, then value of x is between minus 3 and 3. Whenever in mathematics, suppose if you are given x square less than or equal to 25, x square less than or equal to 25, that means x lies between minus 5 and 5. If in any question, if you are given x square less than or equal to 49, whose square is less than or equal to 49, so numbers are between minus 7 and 7, including both. And if here equality is not given, then we cannot take 5 or minus 5. So exclude 5 and minus 5. If here equality is not given, then exclude endpoints. Then this will be open interval. So in this question, these are the numbers whose square is less than or equal to 9, means 9 is greater than x square. So this difference will be non-negative. So its square root is defined. So only numbers from this interval is allowed to put in this machine. So therefore x belongs to close interval minus 3 to 3. So therefore domain of this function is close interval minus 3 to 3. If you select any real number from this interval, then this difference will be positive like this. And if you select any number exterior from exterior part of this interval, then difference will be negative. In that case, output is not defined. So those numbers are not allowed to put in this machine. So domain is the set of those numbers for which output or image is defined. So this is domain. Now we find range of this function. Range means a set of outputs, means set of fx, that values of fx lies in which interval. Say now for range, this calculation is for range. Whenever you calculate range, begin from domain. Here function is defined for these numbers beginning from domain. Values of x are allowed from this interval. For all x belonging to domain, now we create this formula. So x square is between 0 and 9. Now see, explaining this step, here on this line I am representing domain minus 3, minus 2, minus 1, 0, 1, 2, 3. Now if we take square of all these numbers which are between minus 3 and 3, then what happens? See, first of all I am taking square of these numbers. Squares I am representing on other line. Here I will represent square. Here these are values of x. Square of 0 is 0. Square of 1 is 1. Square of 2 is 4. Square of 3 is 9. So square of this part, it will be in this part 0 to 9. Now square of minus 1 is 1, square of minus 2 is 4, square of minus 3 is 9. So if you take square of these numbers, then square of these numbers will also lie in this part 0 to 9. So when x is between minus 3 and 3, their square are between 0 and 9. That is, now we are creating this formula. Now assign minus sign. Now multiplying this by minus sign, whenever any inequality we multiply by minus sign, see, multiplying by minus 1, then sign of inequality will be reversed. Suppose here I say 0 less than or equal to 1 less than or equal to 4. Now this is true. Now applying minus sign, see, relation is reversed. This is now greater, this is greater. So whenever any inequality is given and you assign minus sign, then sign of inequality will be reversed. Here this is the example. This is true. Now multiply by minus 1. So relation is reversed. So that's why here relation is reversed. Now writing from smaller to greater. Minus 9 minus x square less than or equal to 0. Now, so minus x square is created. Now I am adding 9. Step by step we are going to create this expression, square root of 9 minus x square. So in the beginning we started from domain, that x belongs to domain. These values are taken in machine. Then step by step, then after x we have created where is x square, then where is minus x square, now where is 9 minus x square. Now we are adding 9. So adding 9 here, 9 minus 9, 9 minus x square, 9 plus 0. So here 0 less than or equal to 9 minus x square less than or equal to 9. So value of 9 minus x square lies between 0 and 9. Now taking square root, I am taking square root. If any number is between 0 and 9, then its square root is between 0 and 3. Square root of number between 0 and 9 is between 0 and 3. So this is expression for fx. So you can see that fx belongs to close 0 to 3. So range is (0 to 3). So this is the method to find range and domain if such a function having radical sign is given. Now next question, similar questions. Find domain and range of real functions defined by fx equal to square root of x minus 1. As we discussed, domain means set of numbers for which this function gives output. Here it is radical sign. See, formula is fx equal to square root of x minus 1. In this function, if I keep 1, then f of 1 is root 0, that is 0. So define If I put here 2, then square root of 2 minus 1 is 1, that is 1 is defined. If I put 3, square root of 3 minus 1 is 2, square root of 2 is also defined. Irrational number. Here if I keep minus 3, if you keep here minus 3, then minus 3, minus 1, minus 4. This is not defined. Square root of negative number is not defined. Here machine is not giving anything. Putting x equal to minus 3, there is problem. So we are not allowed to put minus 3. Those numbers are not allowed for which square inside radical sign we get a negative number. So here fx is defined, this function is defined if x minus 1, whatever is in the radical sign, this value must be greater than or equal to 0. And these numbers are, it is possible if x is more than or equal to 1. That means, so that is x belongs to closed interval 1 to infinity. So here domain is close 1 to infinity. This is domain. Any number which is 1 or more than 1 we are allowed to put in this machine. Now for range, whenever we calculate range, begin from domain. So here x is in this interval, always begin from domain. It means x is more than or equal to 1. Create this formula, create this expression. We want to know about fx. So creating this formula, x minus 1, because here in the radical sign there is x minus 1, so take 1 on this side. So x minus 1 is greater than or equal to 0. Now x minus 1 is more than or equal to 0, means this is non-negative. So its a square root is non-negative. So that means fx is greater than or equal to 0. So here fx belongs to closed interval 0 to infinity. So this is range. So range of fx is, range of this fx is closed interval 0 to open infinity. Now here this is modulus function fx equal to modulus x minus 1. This function is given. We discuss modulus function. So here in modulus function, if this value is positive, this value is negative, 0, no problem in case of modulus machine. Modulus calculates everything, whether positive, negative, its modulus is possible. So here this function is defined for every x belonging to R. Any number, any real is allowed. Therefore, domain of this function is R, set of reals. Now, for range, we begin from domain. In this machine, any real is allowed. So for every x belonging to R is in domain. If we take any x, then this means for any x, x minus 1, it is also a real. X is real. From any real, if you subtract 1, it is real. Now modulus of any real, its modulus value is more than or equal to 0. Modulus of x minus 1 is more than or equal to 0. So if you keep x equal to 1, then its value will be 0. And for any number x except 1, its modulus will be positive. So that means here fx is more than or equal to 0. So that means range is close 0 to infinity. So set of non-negative real numbers, that is its range. Now next question, find the domain of this function. Say this is rational function. Rational function is defined if a denominator is non-zero. Say here, in this formula there is denominator. Observe denominator. If you keep here minus 7, say look here, I am putting minus 7. F of minus 7 is minus 7 square is 49 minus 4 upon minus 7 plus 7. So 45 by 0. Whenever you get 0 in denominator, then value is not defined. Machine is not giving anything. And if machine is not giving anything, then there is no question of putting this number minus 7. This is not allowed. Problem is due to minus 7. Because of putting minus 7, machine is not giving anything. So that means don't put minus 7. Don't put any number for which denominator is 0. And here there is a number, only one number, minus 7, for which problem we are getting here. So for x equal to minus 7, this is not defined. Therefore, for x equal to minus 7, x plus 7 is 0. So function is not defined. Denominator 0 means function is not defined. So therefore, we cannot take minus 7. So its domain is, take any real, put any real, but don't put minus 7. So minus 7 is excluded from R. So domain is set of all real numbers except problem, except minus 7. Similarly here, this function is not defined if this is 0. Here, this function is not defined. Where it is not defined, let us find those numbers. This function is not defined if x square minus 8x plus 12 is 0. That is, when this will be 0, if x minus 2, x minus 6 is 0. That is, when this product is 0, if x is 2 or x is 6. That means, if we take x equal to 2 or x equal to 6 in this formula, then for these numbers, this is 0. So function is not giving anything for x equal to 2, x equal to 6. So therefore, this function is defined for all x belonging to R, but except 2 and 6. So here domain of this function is R minus 2, 6. This is domain. Now in this question, here f is x square upon 1 plus x square, x belonging to R. function is expressed in a set form, set of ordered pairs, means formula is f of x is x square upon 1 plus x square for all x belonging to R. It means for all x belonging to R, f of x equal to x square upon 1 plus x square. This is the meaning of this statement. Formula is f of x is x square upon 1 plus x square, and this is allowed for all x belonging to R. So here domain is R. Here domain is R. This is given. Here given domain is R. We want range. Range means set of fx, that where fx does lie. Where does fx lie? So we have to create this formula. So beginning from domain, because this is defined for all x belonging to R, for all x belonging to R, now we are going to create this formula. X square is, we know that x square is more than or equal to 0, and this is less than x square plus 1. See, this is always true. X square is less than x square plus 1. It is always true. And x square is more than or equal to 0. Square is always non-negative. For any x, x square is more than or equal to 0 and x square is less than x square plus 1. Using this statement to get range, because see, this is in numerator and this number is in denominator. So create this expression. We are beginning from this inequality. So we relate these two expressions by this way. Now dividing this inequality by x square plus 1. I am dividing this inequality by x square plus 1. This value is always positive. And when we divide inequality by positive number, inequality remains unchanged. So here dividing by x square plus 1, 0 divided by anything is 0. Then here x square upon x square plus 1, here 1. So see, this is fx. So fx is between 0 and 1, but this side closed, this side open. So fx belongs to close 0 to 1. So range is close 0 to 1. This is range of this function.